Hi, everybody. How's it going? We are going to continue from our last video where we're going to now graph some linosomes. We're going to graph them all by hand and in the calculator. So if you don't have your calculator, please go ahead and pause this video and go get it. You will also need some graph paper. This is available on my MCPS Classroom. Go ahead and download some polar graph paper and then come on back. But here we go. So what we're going to first do is we're going to graph all the cardioids. Now, if you remember, a cardioid is the fact where we came out and said the values of A divided by B had to be equal to 1. That's a B. Beautiful. So all of these, 4 and 4, 2 and 2, 5 and 5, 3 and 3. We'll talk about that one in a minute. But the big thing here with all of these is the fact that we have absolute value of A over B is equal to 1, I should have said, because 4 over negative 4 might confuse you. Now, what do we know here? First things first, I'm going to show you how to use your calculator. So you're going to go to mode, and we're going to change this fourth line to polar. I'm going to keep it in radians, then I'm going to go to y equals. Now, you'll notice that y equals makes it a little bit different. It now has r equals. So what we're going to do is plot the first one, which is 4 minus 4 cosine theta. If you notice, the variable button, we already did the first, second, and now we're in the third mode. We hit enter, we hit graph, and I get a beautiful cardioid. If you'd like to see that a little bit closer, you could always hit zoom, and you could zoom 0, which is zoom fit, and it will zoom in to fit the entire curve in one window. Now, whatever that window is, it's up to us. Now, what we need to do is plot that guy. Now, first of all, notice that it's pointing to the left. The reason it's pointing to the left is because it's a minus with a cosine. It'll have symmetry with respect to the x-axis or old x-axis. Because it's cosine, it'll point to the left because of the minus in here with cosine. So what do we have? Well, I know a cardioid's going to hit the pole when theta is 0. It'll hit the pole. Why? Because 4 minus 4 is 0. When theta is pi, it'll go as far out as 8 units that away. I don't have an 8 here. This only goes to 1, 2, 3, 4, 6, 7. So I'm going to go 2, 4, 6, 8. Okay. My scale is by 2's in this particular example. When theta was pi over 2, I'll get a 4, 2, 4. When theta was 3 pi over 2, I will also get a 4. And since we know this is a cardioid, this curve is going to look a little something like so. Now, if you want a little bit more accurate, you can go ahead and plot the actual data points for some things with, in this case, reference angles of pi over 3. But if you also want some more data, if you go to your table here, it's hard to figure out where these angles are, so what you could always do is plot it in degree mode. With your table, this is kind of hard to do. Let's go by 30-degree increments. And there you go. 30 degrees on 0.5 something, 60 degrees on 2, and 90 degrees on 4, and so forth. What did I do there? I did a bunch of things. I put it in degrees. I did second table setup, which is above window. I started my table at 0 degrees, and I went by 30 degrees. You don't have to do that if you don't want to, okay? Now let's take a look at the next one. The next one is 2 plus 2 sine theta. I'm going to put my mode back to radian, and I'm going to hit graph. And I'm going to have a problem seeing the entire thing because this is the window that was set up for my last one. I could zoom 6 to get back to a normal window, or I could zoom fit to see my entire cardioid. Now this cardioid, these values here, the 2 and the 2, when theta is 0, r is 2. When theta is pi over 2, r is 4. When theta is pi, r is 2. When theta is 3 pi over 2, r is again up here. So I actually don't need to go anywhere beyond pi. When theta is pi over 6, r is 3. When theta is 5 pi over 6, r is 3. All right, we'll have a cardioid. This was a little bit easier when I got that one value in between. That'll look a little something like that. Try full symmetry if you can. But I want to talk about symmetry. This one over here is symmetry with respect to the polar axis. Now, the polar axis is something known as your old x-axis. This guy has symmetry with respect to the old y-axis, and that is just the line theta equals pi over 2. And you learned how to plot lines earlier. Theta equals pi over 2 is a line that goes through pi over 2 forever. Okay. Greatness. Now, both of these have max r values. The largest thing r can be here is 4. The largest thing r can be here was 8. Let's do this guy. 5 minus 5 sine. I'm not even going to use the calculator for this. I'm just going to go. Now, what do I know? The largest thing r can be is 10. I know that because the largest thing that the sine of theta could be is 1. The smallest thing it could be is negative 1. How largest I'll get out is 10. Okay. Now, this is going to be in the negative y direction. So I'm going to have a cardioid that goes 2, 4, 6, 8, 10 units down. Again, I'm going to my scale by 2's then. When theta is 0, I'm going to be 5 units to the right. 2, 4, 5, and 2, 4, 5. All right. I could plot some values in between if I'd like. I could do my pi over 6 or 30-degree reference angles. All right. In my pi over 6 or 30-degree reference angles, I'll be at 2.5. It's going to be hard to plot. Yeah, too impossible to plot. 2.5. 2.5. Okay. Here's my cardioid. Now it looks like a better heart for you. It's a little bit hard for me to draw. Now this one looks a little confusing with the negative 3. Does it open right? Does it open left? Not up or down. We have to try to figure out. So let's plug in some points and see what happens. Let's plug in a 0 degree or 0 radian angle. Cosine of 0 is 1. So 3 minus 3 is 0. All right, we knew it. At the pole is the cardioid. Let's do pi over 3. Pi over 3 is here, correct? So that would be negative 3 plus 3 halves, or negative 1.5, negative 1.5. Let's do pi over 2. That would be negative 3. Boom. Okay. Let's do, where are we? 2 pi over 3? That would be negative 3 minus 3 halves, or negative 4.5. 1, 2, 3, 4.5. Let's do pi. That would be negative 3 minus 3, which is negative 6. 2, 3, 4, 5, 6. Why am I plotting it there when I said pi? Well, pi, this is the point right here. This point is the point negative 6 pi. And guess what? That means that this curve, this is the piece of the curve that I just got by plugging in the values between 0 and pi. Now check this out. I want to show you something for a second. You might remember we did negative 3 plus 3 cosine theta right there. if you hit your window right here, we have a theta min and a theta max, just like we had a T min and a T max. And if I let theta max be pi, let's zoom fit first. This will show you what the entire graph would look like. But let's make theta max be pi, and you will only see what I have plotted right there. If I continued plugging in values, I will continue going around the circle in the exact same fashion, where what was this? This is here. This is 1, 2, 3. So this is 1, 2, 3. This was 1, 2, 3, 4 and change. Maybe 5 and change should have been. You're going to see the exact same cardioid that you would see if I made this go between 0 and 2 pi. Okay. Hopefully that helped. I'm going to stop there. This is a video on graphing cardioids by hand. We'll come back and do some others in a minute.